So when you look at this problem, the first thing that you should try to identify is this of quadratic type? Okay? So when you look at this, is 3/2 or 3/4, is one of those double the other? Well, if you took 3/4 and you multiplied by 2, the 2's cancel, you get 3/2. So x to the 3/2 is double x to the 3/4. So if we let u equal x to the 3/4, the smaller of the two, then that means that u squared is going to be x to the, again, 6/4, which reduces to 3/2. And we can substitute in our u's. We get 5u squared is equal to 35u plus 40. And now it's just a matter of solving this quadratic. So we have multiple variable terms, so we're going to move everything to one side and set it equal to 0. So subtract a 35u and subtract a 40. Set that equal to 0. And now when we look at this, can we divide, is there any common factor we can divide by to reduce the numbers that we're working with? Okay, if you notice, we can divide everything here by 5 on both sides of this equation, and it reduces our numbers and makes it easier to work with. And so if we do that and then we look to solve by factoring, first term's used. The second terms are the two factors of -8 whose sum is -7. So -8 and +1. That gives us two possible values for u. And so because we used this u substitution, we do need to plug it back in. So we take x to the 3/4, set that equal to 8. Okay. In order to solve for x, we're going to undo the operation. So you take the reciprocal power of 3/4 is 4/3. So you get x is equal to, and when you take 8 to the 4/3, you can either take it to the power of 4 first, or you can apply the index or the nth root, the cube root first. So I'm going to take the cube root of 8, which is 2, 2 to the 4th, which is 16. Okay. Then do the same thing. X to the 3/4 is equal to -1. Well, right here you can kind of tell. Can you take something that is a 4th root, an even indexed root, and can it ever equal a negative number? No. So you know right away that that's going to be extraneous. So your only potential answer there would be 16.